you very much, Eric.
Thanks, Margaret. It's been a real pleasure with our collaborations going on for so long. And thank you all for coming and enjoying today. So let me pull up my slides.
Volume a little.
Everyone see that, or should I wait a second still, or?
Oh, that's good. We're just going to turn the volume up.
Okay. Check 1, 2. Are we getting there?
No better. Okay, great. Awesome. All right, ready to go. Thanks, Eric.
All right, perfect. Great. So this talk kind of is really built into 2 talks. One that's really the primary focus, which is kind of this notion of real world evidence, and particularly digital therapeutics. You can think about it as kind of like the buzzword of today. You can think about this as digital health and wireless, right? It's just the evolution of language, very much in the spirit of everything Margaret was just presenting and talking on. We're going to be discussing that. And in particular, I want to give a special shout out to one of my postdocs, Milim Kim, who is on this call actually right now. She has been really critical, and we've been working closely together on thinking through something I'm going to show you that we were sort of calling the Digital Therapeutics Real World Evidence Framework. And I'm going to walk you through that. And so the main talk is going to be about that. And the reason for this is because I think it's a way for us to think about how do we really produce evidence that matches the complexities of health and behavior change. But if we have time and interest, I also have a little second, if you will, 5-10 minute add-on slides, kind of exploring the question of what is the role of academia in behavioral health, which might sound a little bit strange on some level, but like particularly after we started building this more and more, it honestly started getting me think pretty differently on what our roles should be. And so we can come to that if you want, but for now, I'm just going to go for that first pass. We'll pause, we'll ask some questions, and then we can see if we want to go into that second half. So first, just acknowledge my many colleagues and collaborators and students who are helping me, and funders. And then I always like to start with my takeaways. So particularly when it comes to digital health, I think there's a real difference between the hope of what we want to get out of them versus the evidence in terms of how they're actually doing. And I think there's sort of 5 dimensions to this. One, I think we have a hope that they can be useful for reducing health disparities, but sadly, I think more often than not, we seem to be propagating health disparities with them. 2, we have a hope that they can be useful for producing desired, sustained behavior change and health effects. But often when we look at the evidence, they tend to be limited sustained use, and therefore by extensions, limited sustained impact on people's lives. We have this hope that they'll be the right tool for the right people in the right time, so they get the real world support in context. But I think the result is oftentimes that they have very low adherence, particularly when they finally become a digital therapeutic company and are out in the real world. We have this hope and dream that they can provide just the right type of support to a person, in the right time, right context, based on their changing and evolving needs. Like they can give you support when you're stressed, they'll leave you alone when you don't need it, right? But the reality is, more often than not, these tools are disruptive, and usually when they do have those types of just-in-time support, they're just shut off. Think about any one of you who has a little buzz from a watch that buzzes you to stand up, right? Do you ignore that? Do you just shut it off, right? Last but not least, and this one has a sort of double edge to it, we have a hope that they will all be, we have a solid evidence base to really justify which intervention to use, which digital therapeutics to use for whom and for what context. But the double-edged sword of this is those who seem really good at building evidence, think particularly academics, are often not that great at actually producing something that can be implemented and sustained in the real world. On the flip side, those who are really good at building technology, such as digital companies, often don't have the expertise to build the rigorous evidence needed, particularly for something as complex as digital therapeutics, which more often than not require you to have a deep understanding of behavior and behavior change. So this is the hope evidence gap. This is sort of my take on where I think we actually are taking an honest reflection on what's happening with our work. And so the question is, well, what do we do then? How do we handle this? And so for me, a big thing is, it's always been kind of an underlying thread for my work, is I'm really interested in trying to make sure the methods we use match the inherent complexity of the problem. And short summary statement is, I don't think that a lot of the tools we historically use, particularly using evidence only, and I'm going to clearly define what I mean when I say evidence, is actually getting us to that level. And so one of the ways to match that complexity is to focus on real world evidence production. And I'll define this more clearly. And then the second thing I would suggest is we might want to think differently about our pipelines of evidence production. And this is what Milim and I and others, Kevin Patrick, actually, who Margaret mentioned, is a co-author on this, Camille Nebaker and others. We've been kind of formulating this idea of a digital therapeutics real world evidence framework. It's a set of 4 steps, 4 phases that we think might be useful to help us to make a more principled, logical, pragmatic approach for evidence production. And so this is actually the first time I've ever actually presented this. So I really look forward to hearing the thoughts and comments on this. This is a paper we're actively developing, but I thought, what the heck, let's see how people respond to this. And then the implications, I think, honestly, once you actually see the end of this, it sort of opens interesting questions on what is the role of academia and how we should do the work. And just to be clear, I am an academic, so I have a bias for this, but I do think we have a role, but I honestly don't think it's the role we've historically been taking. And so we'll get to that if you want to hear my thoughts on that. But let's come back to the HOPE evidence. And let's start with a concrete example. So if anyone have seen this, this is now several years old, this study, but this was a trial done by John Jakisik and others. It was focused on testing, as you can see, a wearable technology in a randomized control trial. And so if you didn't see the results of this, let me show you the summary of this. This is how JAMA suggested that it be framed. Use of a wearable device does not improve weight loss. And so this then was interpreted in a variety of ways. For example, study wearable technology may not help you lose weight. Or this one, what you've suspected about Fitbits all along is true. Wearable exercise trackers don't make people any more active. A flurry of new studies find, even though this one actually only cited this study. Kind of weird. And then this one is my favorite from it. Sorry, your fitness tracker is probably useless, at least for weight loss. So I'm starting with there in terms of this is the kind of conclusions that are being drawn from this type of study. But I want to kind of unpack, well, what happened? How did that happen? And why is this an example of the HOPE evidence gaps as I was framing it? Well, so first, let's just talk about the difference between the mismatch between the concept that was trying to be studied, at least according to JAMA, and even as it was phrased a bit in the paper, versus the operationalization. So the concept was very broad, right? It says it was a wearable device that was being used. So just to be clear, the operation of that, what actually was the wearable device? It was this. It was called a body media armband. And so what this is, it's a relatively large device that fits on your arm, okay? And it was good from a research perspective. They chose it well because it was really good in terms of its assessment capability, in terms of picking up on physical activity and other factors. And it had this app. And so the key hypothesis for this was that this body media armband would be a, quote, lower burden approach to active self-monitoring compared to the lower burden approach to self-monitoring compared to what is traditionally done. And in so doing, that should result in improved weight loss, okay? So this is what they did. But the first question is basically, is this the only wearable device? And of course, I'm sure that you can see the answer is no, right? There's many different types of wearable devices, right? There's 20 different types of Fitbits alone. There's the Apple Watch. There's a whole bunch of different things. I have an Oura Ring on my finger right now, right? That's another wearable device, So first, just the kind of at the level of asking the question, what question was actually asked within this randomized control trial? And I would argue the first problem is it didn't actually ask what they said they had asked. What they asked was something about how does this thing work? Okay, very targeted, right? So then unpacking that a little bit more, the key hypothesis they had was that this approach would be a low burden self-monitoring tool. Okay, that was the hope, that was the prayer. And what they did is they compared it to an active self-monitoring. So both groups basically got the diabetes prevention program, and one group got the digital health tool, this little body media armband, and the other one got diabetes prevention program with the active self-monitoring. And lo and behold, when they ran this 24 months, I think it was 20, I'm forgetting the exact length, but when they ran the trial and they measured weight loss, they found that people who were in the active self-monitoring, the control condition, actually lost a lot more weight. But wait, there was more. And this is now getting to the HOPE evidence gaps. When they actually started digging into the evidence on this, they started to find that that low burden self-report measure and tool, it actually was reported by many of these, this was actually with college students, so particularly college-age women. They found it to be really ugly, to not be comfortable to wear, and to be highly burdensome. And so literally their hypothesized mechanism of action was not true. And so from the standpoint of even their hypothesized mechanism of action, they kind of technically never even tested it. You could think about this more as type 3 error. They didn't even ask the question they meant to ask when they ran this trial. But I want to flag this to say this was not their fault. I would actually say this was a beautiful, rigorously done, randomized controlled efficacy trial. And I would argue that the problem was that they actually ran a rigorous randomized controlled efficacy trial. And they did not think carefully about the inherent complexities that are involved in using a digital therapeutic. And in so doing, they really fell into a lot of because of this strong focus, this love affair with efficacy, I would argue it actually had them overemphasize one thing at the expense of everything else. Right. And so what does this mean? It was really like, okay, well, I'm going to do this nice, tightly controlled thing where I'm going to see how this one little element works compared to this active self-monitoring. Right. And so a lot of the other questions around like, well, who might not use this? Think about the gender issue that was coming out, right? So there could be a gender disparity within this. Think about the desired effects. It was clear this wasn't actually used sustainably, so it didn't have a positive effect. It had poor adherence. It was actually shut off. People stopped using it. And it actually was poor implementation. And this one's an interesting one because it was actually, by the time this paper was published, so forget the, after any other time, by the time the trial was done and the paper was published, that body media armband was already taken off the market. Why? Because it wasn't very well used. It wasn't very sustainable. It wasn't a very good commercial product. And so they studied something that if they actually just did some initial design work, they would have realized much quicker that they weren't actually going to be able to test their hypothesis in the first place. And so the summary statement that I want you to take from this, as I'm summarizing this in the study as a context, is we have this love affair with randomized control trials and particularly efficacy trials, this love affair with trying to really get this really strong internal validity. And I think it comes at a huge cost when we're working on something as complex as digital therapeutics. So let me try to unpack what I mean by that. There's this mismatch between the inherent complexity of behavior and the evidence we're producing, and so just as an example, this is from Bess Marcus, and Bess is a friend, mentor. This is not to critique this work. This was fantastic work in 1998, right? This is basically what we all want to see, right? Our intervention worked better than our control when we do these little snapshots approach. But now that we have digital devices, we can start to see that maybe that behavior is not quite this simple. And so this is work from one of my former postdocs, Guillaume Chavants, now a faculty member in Spain. This is highlighting, this is basically and this is not cherry picking. This is a highlight from a few people taking part in a weight loss intervention, much like, and actually kind of a sister to that project that I was describing. Was called SMART 2.0, led by Joe Godino as the lead PI on this. We gathered data to explore how people's physical activity change. And what you can see from this is variation is much more the norm, not the exception. There's all sorts of these fluctuations on times when people radically change their behavior. Very different from this nice clean linearity. This is hiding this level of complexity. And I think we all intuitively know that human behavior change is complex, right? We have theories about this. This is the behavioral ecological model. I summarize it when I say complexity, I define that as having three key elements: the degree to which context matters, the degree to which history or time matters, and the degree to which people adapt to their context, or therefore by extension become different. The more likely that context, time, and individual differences matter causally to a phenomenon like a behavior, as you can see, the flowing of all these external things outside the skin and inside the skin over time, the more likely it is that causally you need to account for that complexity in your evidence production. And if you don't, you're probably going to get something wrong because you're not actually really studying the inherent complexity of the phenomenon. You're not matching the complexity of the phenomenon with methods that can handle it, okay? So that's the problem. Now, what do we do about it, right? That's the question. And I would put, coming back to kind of basics on study design work, invite you back into a classic, Shadish, Cook, and Campbell, 2002, Experimental and Quasi-Experimental Design. They talk about the notion of generalizable knowledge. And just if there's one thing you take away from this study, from this talk, I want you to remember this. Generalizable knowledge is a really hard concept that we talk about all the time as if we know what we're talking about, and I don't think we actually do. And so I want to at least highlight two key dimensions to generalizable knowledge. One is the one that I think most people think about, and I would use the word transportability, building on the work of Judea Pearl, one of the global experts on causal inference. The notion of transportability, you can think about this as basically, how do I take insights from this one space or time, people and context, and transport it somewhere else? Is it justifiable from an evidence perspective to say what I learned here is transportable to somewhere else? Okay, that's one type of generalizable knowledge, transportable knowledge. There's another type though, which is about predictive knowledge. And by predictive knowledge, it's focused on time. The idea here is, in context, can I get better at predicting future responses? And what I would argue, and what we're particularly trying to build out within this digital therapeutics, digital therapeutics real world evidence framework, we're trying to actually build into a process where our goal is still getting to transportable knowledge, but we're trying to do that in a way that's rigorously accounting for real world context. And so it's building up from predictive knowledge. Now, how do we do that? How do we show that? Now I'm going to start transitioning into that kind of line of thinking. Well, the key difference is to actually shift your frame of mind from evidence production, which is, I think, what you're used to when you think about efficacy trials. So think about, you're doing something in ideal conditions. You're really trying to prioritize internal validity of that one local molar causal inference. That's another phrase used by Shadish, Cook, and Campbell around causal inference. It's basically saying, does this package seem to influence this outcome relative to this other package, right? It's very much explanatory. So it's really trying to zoom in on this one linear causal question that you have. And by extension, then the transportability claims, you can do that, but it's often only justified to really be transportable to similar settings and contexts. And so therefore, often it's really just another highly controlled setting like it. And so with that, the more and more you're getting into complexities, the more that these things are actually used in real world contexts, the less likely the evidence actually is going to be at all relevant to it. And it also, because it has this strong focus on this one question, this causal inference of the intervention to control, it tends to be it almost sort of, I mean, think about what randomization doing, if nothing else, but it's actually trying to erase history. You know, that's what are you doing with randomization, but you're trying to clean out all the causal factors that happen prior to a given moment that you care about to have an impact. So with that, it actually sets you up to actually sort of almost have these little 5-year increments and only think in those sorts of terms and not necessarily be able to look at a long time series of data. And therefore, it's not that functional for actually getting meaningful predictive knowledge, okay? There's a time and a place for it too. I'll come back to that more at the end, particularly if we get to that academic conversation. But in brief, I'm inviting you to put this down for a moment. Imagine we weren't actually in the business of evidence production, and instead our goal was real world evidence production. And by this, I mean that the work is being done within real world context. So it's being done in partnership with community clinics, with communities themselves. It's focused on prioritizing the ecological validity of the knowledge. And why? Basically because if time, context, and individual differences matter causally, then you need that variance in your work to actually understand how something is going to work. It's at a basic phenomenological level. You need that variance to actually study it. Okay. It's also, while that sounds really, trippy on some level, it's also very pragmatic, what we're trying to work out here. We're really trying to say, how do we use evidence to get better at improving care here and now? Okay. Now, and with that, I think I'll hope to show you with that, this really drives you towards being able to actually produce more predictive knowledge. There's a great potential for predictive knowledge, was a key argument I'd make. And then last but not least, I should have probably flipped these two. Transportability claims, because they're actually being done in real world context, it increases your capacity to actually make claims to move it from one real world context to another. But I'll show you, as you really start thinking about real world evidence, or at least as we have, there's a lot of caveats that we think there's actually a lot more rigor we should be adding in to our notions of transportability and external validity in our work. Okay, so real world evidence is basically it. We're going to be trying to focus on what would happen if we were trying to build a digital therapeutic and consciously do it within a context of real world evidence production, not evidence production. So we're not doing efficacy trials. We're doing effectiveness is the one linkage to it. Okay, so that's the starting point. How would this work? I'm sure you're asking that question, Lila. Let me walk you through our idea, what we think might make sense. First and foremost, real world evidence requires a real world partner. This is not something that you do in an academic setting where you come up with this cool idea and then you go find some random group of people to try it out. That's all ideal setting logic. This is something where you're meaningfully, deeply think community-based participatory research or participatory action research or community-driven design. These various methods and approaches where you have an authentic, meaningful, sustained relationship with people in context. Noting here, we're moving towards this notion of getting better at predictive knowledge, getting better at making things work better in context by getting better at predicting what works and what doesn't work here. Okay, so I'm going to work through this actually with a concrete example, and this is with an idea. Honestly, we haven't been funded to do this just yet, but I'm hoping we will. One of my close colleagues and friends, Joe Godino, he is the research lead at Family Health Centers of San Diego. This is the largest federally qualified health center in San Diego County, and if you probably don't know what that means, it's a weird. Our healthcare system's crazy. The short summary statement is that a federally qualified health center is a group that is specifically there to be the sort of last line of defense. These are the groups that picks up and provides support to those most underserved, most in need. And so this is the group that we're thinking about, and we are actually thinking very much around the notion of hypertension as an area for this. So with this, what would we do to try to build a digital therapeutic in this context? First and foremost, just as kind of a bit of an aside, I think ideally you would have someone, a group, a digital therapeutics company actually doing this, so not an academic, but a digital therapeutics company doing this in partnership with Family Health Centers of San Diego. The reason is you want somebody that will keep the code up to date and maintained such that you don't fall into the, oh, I just finished my trial, oh crap, now I can't keep doing it, right? The thing has to be built in a way such that you have sustainment in mind. Okay, so with that, it's a partnership actually between, I think, a digital therapeutics company and a real world clinical partner or a community partner. This could be done in a public health practice as well, but let's now stay in a clinical context for this moment. So we basically tried to take the general ideas of the 4-phase development model that I'm sure you're all aware of for evidence production, but translated into something that we think better conforms with real world evidence production. And the 4 phases that we suggest are design, develop, test, and monitor. And we made adaptations to each one of these. You can see we were trying to clearly define the sets of activities. That's what's in these little ovals. And then the decision points, the go, no goes that would allow us to move from phase 1 to 2, 2 to 3, and 3 to 4. And also, because this is complex, pathways for iteration within this. Particularly you can notice the last question, this idea of real world evidence monitoring. This is where you're constantly monitoring time series and long term, and you're checking if there's actually diminishing effects that are happening with this. And if it is, forces you to actually go back to the drawing board with this, so to speak. Okay. So this is the general frame, and I want to now walk you through each one of these stages in a little bit more detail to help you see how would this work, how does this embrace the complexity of people, place, and time, and how might this be useful for actually us to build more rigorous evidence that would actually, I think, hopefully help support more people in an equitable, thoughtful way. So let's start with design. So the design phase is really around defining what the problem is and what's a plausible solution. Okay, and so the decisions are basically around, for problem specification particularly, have plausible needs, assets, constraints in the sustainment plan been defined? If yes, great. Can you build a minimal viable product, and can you build smart, and this is the specific, measurable, actionable, realistic, timely benchmarks been defined? And if you haven't, go back. And if you can go on to the next phase. So what is this? This is really recognizing, putting on my design lab hat and director of the design specialization. I teach human-centered design, community-driven design. This is design. This is human-centered design 101. This is one of many variations, but you can say this is basically problem specification, design the right things, and then solution specification, design things right. And so this is pulling on our knowledge from human-centered design elements. You're trying to build out the tools, recognizing and honoring real-world constraints. Okay, and so, and you can see explicitly as how we drew this, these things should be going back and forth with each other. That we don't think that, it's a very clearly, you define a problem and then you define a solution. These in design is constantly going back and forth, hence this idea of how this cascades. But ultimately, your goal here is to get to this idea of a product, a solution that actually might be meeting some real world goal, this smart benchmark. So what do I mean by this? So going back to this one of this hypertension care within family health centers, we're thinking about provide, and we actually got a grant from HRSA. So this is another funding group that actually supports clinical care, particularly for underserved populations, where we're actually giving digital blood pressure monitors to patients all in the clinic. And what we're thinking about is basically what would happen if we provide SMS-based support, particularly on medication adherence, and then also telehealth coaching. Those are the kind of basic elements that we're thinking as an intervention to support this. And then most critically, and this is a key concept, is this from this idea of real world evidence development, is the idea of setting very meaningful, actionable, ambitious, while also achievable benchmarks that you can define without any need of inferential statistics. So, and there's a whole literature, I'm going to show you a book soon where it walks into this great depth. I really invite you to read the book. It's a great book. But the general idea is when you're doing small stage work and you don't have large samples, you shouldn't be running inferential statistics. You're not going to learn anything from it. If anything, you're actually hurting the field when you do it. So what do you do instead? You define real world meaningful benchmarks that are ambitious, but also achievable within your localized context. And there's actually many dimensions we were thinking for this. So effectiveness, safety, health equity, sustainability, both ecological and financial. For now, I'm just focusing on effectiveness and safety. And so you can see the idea here is the ideas we're thinking is 70% of our population will move from being hypertensive to being non-hypertensive. And we'll have less than 10% of people using this thing having any non-serious adverse events. Okay, so with that, if you have that, the idea is you can move on to into the next phase, development. That's basically flowing right into here, okay? So then the next question is basically, do any of the elements of your digital therapeutics need to be improved or tested? So you just created up a minimal viable product. Is it enough? Can you run it? If you can, basically, if there's no need to do any improvement, you could run what's called a proof of concept trial, okay? And I'll walk through that. And if not, you can run an optimization trial. And I'll walk through each one of these as a starting point. Okay, so a proof of concept trial. This is the book that I was just mentioning by Powell, Friedland, and Kaufman, Behavioral Clinical Trials for Chronic Diseases. I highly recommend this book. This is really debunking a lot of the myths and ideas on how we do good clinical trials work for behavioral interventions. It's excellent. One of the key concepts that they're trying to articulate within this is this notion of a proof of concept trial. The idea here, as you can see, common questions. In a small, highly selected sample, is it plausible that a fixed treatment package can produce a clinically significant improvement in a behavioral risk factor or a clinical endpoint? So notice, this is that SMART benchmark. Basically, it's trying to run something in a real world, well, I think a real world context, they're thinking efficacy. So that would be the one difference on this. But same basic idea, running a quasi-experimental or N of 1 time series and seeing if you can get a meaningful clinical benchmark hit or not. If you can, great, you can move on to the next phase. If you can't, well, you got to go back to the drawing board and keep iterating until you get something that's actually clinically meaningful. And again, clinically meaningful in context. If you're working with an underserved population, maybe all you can get is 10% of the population to pre-hypertensive. That might be good enough if you're working with a particularly underserved population. You should know that. This is coming back to honoring and recognizing context. But that's the idea within this, that you're really trying to shoot for that. And so let me show you. This is basically why you can see why that benchmarks from phase 1 immediately can flow into this. You have your intervention elements. And then what you do is you design a study, so maybe a 3-month pre-post comparison where you're comparing hypertension levels, baseline to 3 months afterwards. You do this just in this 10 patients at first. And what you're looking for is descriptive statistics suggesting that it's effective and safe. That's it, right? And if you can hit these benchmarks, great, you move forward. If you can hit these benchmarks, you should probably go back to the drawing board, particularly because you might need to do some improvement on your elements. And that might flow you into optimization. So optimization, there are many optimization trials within this. This is particularly building on the work of Linda Collins and the multi-phase optimization strategy. Oh, and I should have noted, this whole thing was very much inspired by Susan Chakowski's work and others on the orbit model. We've adapted the notions of the orbit model, and that was a central thing within that book that I just described. We've adapted the orbit model really for digital therapeutics and this notion of real world evidence rather than evidence production. So with this, moving into this, with this optimization, this is building on Linda Collins's work and the multi-phase optimization strategy. So there's many different types of optimization strategies or trials. the factorial trial. There's a thing called the sequential multiple assignment randomized trial, also called SMART trial, but I won't use that word SMART because I'm talking about SMART benchmarks. I don't want you to get confused. So sequential multiple assignment randomized trial, I'll say the whole thing. There's also micro-randomization trials. There's also ones that I've helped to invent, like the control optimization trial and the use of system identification. For now, I'm just going to show you one. And I'm going to show you the micro-randomization trial. And so this was invented by, in particular, my colleague and friend, Susan Murphy. Here she is. The basic idea is it's a factorial trial. So it's a randomized control trial, but it's sequential. So rather than randomizing between people, what you're doing is you're randomizing each intervention component each time you might deliver the component within person. Okay, so it's like if you're going to feasibly send an SMS notification to nudge people to take medications, you might do that every morning or not. And so you randomize delivering it each morning. Some mornings you get randomized to get a notification, some days you don't. Or another example, the telehealth one, maybe you think you might do weekly telehealth coaching. You can randomize that. Once a week, you randomize, and some weeks people meet with a coach, some weeks they don't. That's the basic idea, okay? And you can randomize multiple components at the same time. And sorry for that. And potentially randomize hundreds of thousands of times. So you can actually get quite a bit of power from this type of trial. So what would this look like within this example, right? Same patient sample. You can notice here, this is actually a power trial. We actually did design this. So the idea is telehealth coaching or not, with the idea, the key notion here is you have a proximal outcome. So what you're doing is you're measuring not pre-post, you're measuring on a weekly basis. And so this is why you particularly need digital health tools. So we need the systolic blood pressure. So the idea is we're actually measuring on a weekly basis what the systolic blood pressure is and averaging it out and basically comparing 1 week of systolic blood pressure measures to others. So we can compare weeks when they've met with a telehealth coach versus not. What did that do to their systolic blood pressure? We can do the same thing with medication adherence, and this where we're going to use a pill cap and measuring the percent of adherence to their hypertension medications and other medications to see the impact of getting these SMS reminders or not. And then notice there's this idea in that question of optimization criteria. This is really just saying, what is success? It's the same idea of that SMART benchmark, but applied to an optimization trial. And each optimization trial has its own kind of flavor on how you set an optimization criteria. For here, the basic question is, are each one of the components doing something? And you can see that from evidence from the micro-randomization trial. And you can also ask questions of optimizing it. Notice here, taking into account real world context. You can start to gather data to figure out when, where, and for whom these different intervention components will work. So you might find that medication adherence, these pill reminders are only useful on weekdays and maybe not on weekends. Totally observable and studyable rigorously from a micro-randomization trial. Okay, so you can run a trial like this. And if you hit your optimization criteria, you can move on to phase 3. Phase 3 is testing. Okay, so what is the goal of phase 3? First question is basically you need to ask yourself, is there evidence available to show an effectiveness trial can be conducted? And if there isn't, don't run one yet, run a feasibility or pilot trial. Okay, and this is oftentimes in the efficacy world, this is a phase 2 effort. We're consciously labeling it as phase 3 because we see this as in service of the ultimate goal of testing the digital therapeutic. Okay, and so you can see it's basically a little recursive loop, right? Like run feasibility trials or feasibility or pilot trials, and I'll define the difference between those, again, building on Powell and et al.'s work. But run a feasibility trial until you actually have evidence to suggest that you can run your trial. Can you produce the evidence you need? Notice, coming back, if I may, to the previous trial, the stuff that I was showing from Jakisik and else, right? If they had done more rigorous work on this, they probably would have noticed that their adherence markers weren't actually strong enough, right? Or proof of concept. Like a lot of these things would have been caught much, much earlier and suggesting that they would have never run that trial in the first place, okay? I hope you can see that. We're building up robust evidence. But if you have it, you can run an effectiveness trial. And this is, I'll describe the difference between this versus an efficacy trial and the ways that we're conceptualizing them. But let's first start with a feasibility or pilot trial. What is this? Again, building on this book, great book, strongly recommended. There's a difference between pilot studies, feasibility studies, and the broader behavioral treatment studies, okay? And this is the way that they frame it. The idea of a pilot study is that, you can see, it's these types of questions. At a very fundamental level, the pilot studies is you're not piloting the intervention, you're piloting the randomized control trial you eventually want to run. Okay, you're piloting that, in this context of real world evidence, the effectiveness trial that you want to do. You want to see if you can do it. Can you actually randomize people? What happens with dropout? Can you produce evidence that would actually allow you to make conclusions? If you can't, keep going back to the drawing board, because you just won't produce the evidence you need. Feasibility, it's a bit of a broader context. This could be one type of feasibility trial, but you don't necessarily have to do randomization. And I would really invite you to read the book. They go into scathing detail on why our way that we do early formative work is really bad, unfortunately. I'm not going to go into the depths, but read it. I find it very compelling, very smart. And that's why a lot of this ideas that we're showing here doesn't do I'm going to run a limited efficacy pilot trial. That's a horrible method. Don't do it. Okay. Read the book to understand why. Okay. So imagine you run this little feasibility trial and you can show to yourself, yep, I've got the evidence to say I probably can actually run an effectiveness trial. Good job, you. Now run an effectiveness trial. This is what we're shooting for here. So now what's the difference? In a phase 3 efficacy trial, so if you're in an evidence place, not a real world evidence place, your focus tends to be on explanatory knowledge. You're really trying to get a sense of, does this intervention work in ideal conditions, right? And so there often are limited generalization checks, and I'll define exactly what I mean by that. Oftentimes the default tends to be towards something that is really close causally, so like a double-blind placebo is the ideal. And really, from a perspective of transportability, it's almost assumed that if you get a statistically significant effect, it will be transportable. That is not the way that we're thinking about it when we think of a phase 3 real world evidence effectiveness trial. Okay, what we're thinking about is notions of pragmatism and being very thoughtful on the selection of the comparator such that it's supporting a real world decision that would be made. We also are recommending that we use a modified re-aim consort diagram, again, with the notion of smart benchmarks to actually make claims, to actually produce some degree of evidence to suggest that our claims of transportability might be justifiable. And then this is a push, but maybe even actually developing what's called directed acyclic graphs as an approach to test these. And so this is again from Judea Pearl. Let me unpack what I mean by each one of these. So first, in terms of pragmatism, I invite you to look at the PRECIS or PRECISE-2 model. This is that. So again, building right out of standard practice work. It's the idea of how pragmatic is your trial. On the left is highly pragmatic. So this is like taking into account how flexible is your comparator condition, how much expertise is needed from the practitioner. It's best if you need as little expertise as possible. How flexible is the experimental condition? How open are your eligibility criteria? How complex are your primary analyses? How much are you controlling for? How intensive is your follow-up? How hard is it to get your outcome measures, right? And so efficacy trials tends to bias towards as much control as you can. Effectiveness trials and pragmatism tends to focus for the other. And so let me show you like an example, right? So this is the visualization of these two different types of trials, right? Eligibility, all comers receiving care for newly diagnosed tuberculosis. Lots of inclusion-exclusion criteria. Self-administered, why the individual for the intervention flexibility, very restricted. Practitioner, all clinic nurses were involved, no new training. Practitioner, they needed advanced training to actually do this. And I won't continue, you can read. But that's the idea, right? Notice every time you're making a decision to get more and more explanatory control, you're probably reducing the likelihood that this would ever be possible anywhere else. That's what we're trying to work on within this, okay? So the first step is basically to try to bias. Our bias and our recommendation is basically bias towards pragmatism, and you need to justify going more explanatory. And that's okay, by the way. It's good to justify explanatory target. There's times when you need more control. We're just flipping the logic. We think in efficacy, the bias is towards being as controlled as possible, and you had to justify being more pragmatic. We're saying do the opposite. Be as pragmatic as possible and justify being more explanatory. Okay, so that's one. 2, this notion of decision supporting comparator. Again, fantastic book, really cool ideas. Although I think they're building in an efficacy, not a real world evidence, but there's a lot of elements that we are completely in agreement on. And one of them is the notion on how to select a comparator. And notice this is a framework that particularly Ken Friedland in an initial paper wrote, and then they picked up and built on it in this book. But the key idea is know what the primary purpose of your trial is and select a comparator that's meaningful for that. Right. So if you are trying to, for example, support family health centers, if there is a current standard of care on hypertension management, you might want that to be your comparator. Now, from a pragmatism, this is great because what you're doing is you're producing evidence to help family health centers make a decision. Should I use the standard of care or should I use the digital therapeutics? You see it, right? But that also might not be right. Maybe there is no standard of care. And that's actually the example we're working from. And I won't go into all this. I really invite you to read this because I don't have time to get into this, but very thoughtful on how you do meaningful comparator selection. So in our context, what we were thinking about would actually be moving towards what's called the stepped wedge trial. It's a variant of like a cluster randomized trial. What you're doing is you're actually randomizing at the clinic level. Why? Because at this point, there isn't a robust standard of care that we think this digital therapeutic would replace. We're trying to ask the question of, does this digital therapeutic result in improved care across family health centers? Thankfully, this actually is not true. This is from a different trial. They don't actually have 90 clinics, but they do have a lot. I think they have like 50. So we can, what you do is basically you randomize when different clinics start to receive it. Every clinic gets it with a different phased launch. And what you're looking for is the impact and change in your measure, your primary outcome, in this sense, systolic blood pressure. This is a pragmatic clinical trial that can produce meaningful evidence. There's great work on stepped wedge clinical trials that would help you to actually make a meaningful decision, particularly for family health centers. Should I start to implement this? Okay. Now, if you really want to push this and you want to try to make claims of that base, so you can think about this in terms of the predictive knowledge. This is really good predictive knowledge, right? This is asking the question of when we rolled this out, how well can I confidently make a prediction that this will keep being useful? Right? That's what this evidence is producing. It's predictive knowledge that is immediately useful for family health centers. Okay. And you can feasibly produce this to also move towards transportable knowledge. And you've already taken into account all of this context because you've done this meaningful design, you've done this meaningful iteration, this development. And what we invite is another classic model. This is the ReAIM from Russ Glasgow, the ReAIM framework, where what we want you to do is basically pay in particular attention to notions of reach and adoption. Who are you helping, where, and who's delivering it? Right. And so what you can see is this is a modified consort diagram. The original consort's down here. This is how it works from the perspective of modified one. And notice it's these earlier ones, basically like, what are the total number of plausible eligible place settings that you could have done this? So that's like, what are every single family health center clinics that you could work with? How many of them were excluded? How many of them actually participated versus declined, right? And then of those clinics, how many of the staff actually were systematically excluded? How many declined? And then from that, how many people were actually among that population potentially eligible versus those that actually took part, the reach, right? And so coming back to the notion of smart diagrams, if we're trying to think about this for a clinical trial, we can ask the question of, we can actually set benchmarks here. And these I think are actually very ambitious. I don't think this will actually be true, but just to give you a sense of this, right? Like imagine 80% of all eligible clinics take part. And that means they not only are not excluded, they're also not declining. And then 80% of the clinical staff take part, they're not declining. And then say 60% of eligible patients there take part in that stepped wedge trial, right? If you had this type of evidence, think about what you can make claims on in transportability, right? And also just ask yourself, how often do you think any efficacy trial is ever near this? If you're honest with yourself, the answer is no. They're nowhere near this. You know, it's not real world evidence production, it's evidence production, you know? So this is the benchmark that we're thinking about, right? And then just to push it even farther, and this one's a little more speculative on my side, but I think it's kind of fun. Imagine that you're actually carefully hypothesizing transportability. And so this is a relatively simple one. Imagine that socioeconomic status would have an impact on study enrollment, on adherence to your digital therapeutics, and improved hypertension. Okay, so what would that look like? I could actually articulate hypotheses of transportability. That socioeconomic status will impact the percent of individuals who will enroll among those contacted for the study. So individuals with low, medium versus high SES will have significantly different enrollments among those contacted in each group. This is important. If you're basically enrolling people and you think and you're trying to make a claim that will be useful for everyone, even low or medium income individuals with socioeconomic status, prove it, show it. Show it from a hypothesis, not just from a hope and prayer, which is what efficacy trials invite you to do. And it hides you just don't see it, right? Individuals with low, medium versus high SAS will significantly impact their digital therapeutic adherence. Again, think about how much harder of a life someone is having and who has less resources compared to those who have a lot. Think about the ways in which yes, people just have that knowledge on how to use digital devices and use a blood pressure cuff, the more resources you tend to have, right? That should be counted in. And then ultimately asking the question of, is there differences in SES drops? And you need to be able to show that there aren't any significant differences. The assumption is that you have to prove it, not disprove it, right? And so this is testing your transportability rigorously. This is the way we're thinking about it from a real world evidence perspective, okay? If you pull that off, then the goal is to move on to real world monitoring. And I'm not going to get into great depths on this, but the key idea here, coming back to this idea of like, what would be the incentive for a digital therapeutic company to do this, all this? It's one, is basically you're producing evidence, so you're actually making something that's useful. But two, what we're thinking about is that what if this were picked up as the regulatory pathway for regulators across the world? You know, what if the FDA used this? What if, I don't know, I'm sorry, I don't know Australia's regulatory body, but basically what you're saying is you can't market this to a target group until you actually get that level of evidence. You can do something, you can sell something, but you have to do it in partnership with clinics or other communities until you get to this level of impact, right? So if you show this, then the targeted group, justified by that transportability hypothesis, justified by your benchmarks of effectiveness, you can release it to that marketing. You don't need to be in partnership. And then what you can do is you engage in real world evidence monitoring. You have like basically part of the digital therapeutics should be to keep monitoring how adherent are people? How do you know your thing's still working? And basically you can ask these three questions. Is there any diminishing positive effects over time in real world use? This is really critical for digital therapeutics. I mean, just think about it this way. If you're trying to build, imagine you are building an intervention to support suicidal ideation risk among teens, and you built it on Facebook in 2010. Think about it now. Do you know the percentage of teens that are on Facebook? It's very low. They've moved to TikTok. They've moved to Instagram, right? They're not on Facebook anymore. And so the technology is constantly changing. You can't possibly assume, there's no notion in this world of a definitive trial. It's literally an impossibility because it's recognizing that time, context, and individual differences matter. So you need a constant real world evidence to monitor if it's still useful or not. It also, by the way, I hope you can see, invites that a digital therapeutic into asking, can I improve this? Or can I maybe expand my market? And if they do, you can then go back to the beginning, all the way back up, design, work your way through in partnership with others. So this is basically the idea, and this is my ending of my first half of the talk, if you will. Hope evidence gaps exist within digital therapeutics. We have a hope that they will reduce health disparities, but they often propagate them. We have a desired effect, but they're not used in a sustained fashion. We have a hope that there's this real world support, but they're often low adherence in real world contexts. They often are hopeful to be providing just-in-time support in context. They're often disruptive and turned off. We hope that they're evidence-based, but we're not actually producing rigorous evidence to actually get, when we produce rigorous evidence, like the trial I showed you as an example, it's often so explanatory and so controlled that the evidence is functionally useless for real world context. And the digital therapeutic companies that are working in the real world, they don't have the rigor to be able to ask things more in the spirit of real world evidence. So it's either poor implementation or poor evidence, or sometimes both. What do? Let's focus on real world evidence production in partnership, where digital therapeutic creators and clinics and communities work actively together, honoring and embracing the real world complexities and trying to get something that actually meaningfully works and hits real world clinically meaningful outcomes. And then with that, to guide that and try to simplify it into a logical series of steps, follow what we're suggesting as the digital therapeutics real world evidence framework. Produce the evidence needed that actually embraces this complexity. So that is my talk. I'm going to pause there. I can get into a whole question on what is the role of academia, but I'll just stop there for now to answer any thoughts, comments, and questions.
Thank you very much, Eric, for synthesizing all of that together, which is kind of ways that I've thought over the past decade. I'd like to give people the opportunity to ask some questions, but I must say I'm really interested in the role of academia because I've gone from an enthusiast to wondering just what is our role in all of this. But perhaps we could take some questions from the audience first. Thank you. So this question is going to be from Manos Stamatakis, who leads our physical activity theme within the Charles Perkins Centre.
Yeah, hi, Eric. Thanks for a truly wonderful talk. You mentioned that technology is changing very rapidly, and you very beautifully illustrated how that armband was completely out of date by the time the JAMA paper was published. So here, I think when it comes to the evaluation of wearable devices-based interventions, we do have a serious problem because the typical life cycle of most products is 6 to 12 months. A new model is coming out every year or so by most manufacturers. So how do we mitigate against that? So there's a stark contrast here with how research funding and research operates. A typical trial, from the time it gets funded to the time it gets published, I think the time frame is 4, 5, 6 years sometimes. So we have potentially 10 new models of that device that was tested. How do we deal with this problem in the context of this pragmatic, very nice framework you described, the pragmatic evaluation of the TX interventions? Thank you.
Awesome question. And the short answer in my mind is this is why the partnership is so critical, and why for me, I actually, and Milim and I've discussed this and others in our team have discussed this, particularly Job, thinking with family health centers, we really think a key thing should be is actually trying to disincentivize phase 3. You know, because what you're basically hitting on is that we need more phase 1 and phase 2, and we need time to do that well. Right. And so to me, phase 3 only makes sense. And this is in a different paper that I was a co-author on with Elizabeth Murray and others on basically trying to produce evidence for digital therapeutics. So very much inspired. I co-wrote it. So, but those ideas were pulled into here. So one of the key concepts from that writing, which is in the paper, is this idea of moving to phase 3. A key underlying requirement is basically is it stable, right? Like if you have not yet gotten to a fully stabilized space, maybe you should still be doing it in partner. And notice, I didn't say that you can't have many partners. Imagine a digital therapy company is working, and a wearable company is working with a variety of different partners in a variety of different contexts. The key is that you're doing it in a thoughtful, concerted way where you're actually accounting for the real world complexities, right? For that design phase, phase 1, for the development phase. And what you're doing is you can work, and you can, and this is a key thing from like an incentive. How could we incentivize this? Like one of the ideas that we actually write into the, recommend in the paper is, what if digital therapeutic companies and groups could actually get reimbursed for particularly, I think, phase 2 development work, right? If it's good enough such that they're actually showing some degree of clinical utility in the spirit of what is currently happening within like a federal qualified health system or whatnot. Let them get paid for it. Such that you're actually reducing the barrier, and you're actually also reducing the incentive to rush to phase 3. Right. So it's obviously that there's a lot of layers of complexity of what I was just kind of unpacking with that. But at a high level, it's like, in my mind, we need to actually disincentivize phase 3. And we need to incentivize phase 1 and 2 and make it sustainable for people to actually meaningful stay there until it actually stabilizes enough to actually ask the question of, should I try to share this? Did I make something that's actually meaningful for a target population that others should engage with outside of my partners? If so, great, do phase 3. But I'm honestly thinking, like, think about this as like building an incentive structure for like local mom and pop digital therapeutic companies, where there's the local digital therapeutic company supporting family health centers or supporting people in the San Diego region, just like there would be a digital therapeutics company supporting the local needs in Sydney, right? And then of course you can share notes. That's great. That's fine. But it's actually consciously pushing away the current incentives, which is around monopolization and standardization. And I just hope you can see the very clear tension that happens between the desire for scalability and the desire to actually meaningful advance equity, which requires you to take into account people, place, time, context. Right. So that's basically the way there's lots of layers to answer that, but it's undergirding, it's second layer thoughts that we're thinking about that we think actually maps on nicely to the framework that we've articulated.
Thank you.
Thanks, Eric. That's my question too. And I actually think that we need to try and do something in Australia about the funding. And the paper by Kwasnica, which you were an author on, who's now moved to Curtin, talks about the very problem of needing to fund phase 1 and phase 2.
Funding. Yes, totally.
Yeah, and she's here now at Curtin. We need to do something about that because everything in the NHMRC goes against us being able to do any of this work well. So maybe that's an action for us to take.
Can phase 2
totally
be published in JAMA?
That's right, that's right. He wants to know, can you publish it in JAMA? Which
Publish
is
what in
publish
this?
phase 1 and 2, yeah, because that's kind of like the problem we have in Australia, which I have been explaining to Eric a bit over the years, yeah.
Well, it's not published yet, so I won't share where we're shooting, but we are shooting for a pretty solid journal. So, but I'm not going to say it just in case we don't get it. And then I look bad. So.
Thanks, Eric. Thanks. So do we have another question? I mean, I've been thinking about this, how this might relate to some of the work we do with New South Wales Health. I don't know if you've got a question, PH. I'd like to take a few more questions. It's only 10 to 11, so if we could just do a few more. Yeah.
I mean, Margaret, I also have those other slides if you want, because you did want to know about the role of academia, if you'd want me to go there, but I don't have to. I'm fine either. Whatever the group wants to do.
Yeah. Anna.
Hi, Eric. It's Anna. Yeah, it's just really interesting. Like yesterday, we were talking actually about a feasibility trial and the sample size, what would be an adequate sample size, because the ethics committee was thinking of it more in terms of an RCT rather than, feasibility. So what do you have any suggestions maybe for, responding back to the ethics committee? I mean, I guess we could quote the book that you've suggested.
Yeah, I look at the book. There's great answers in that, Anna, but short summary statement is if you're treating it like a small scale randomized control trial, let me rephrase this. Randomized controlled trials are very fragile in that the evidence you're producing is only interpretable in a very limited context, right? And it basically comes down to do you have a large enough sample to actually run inferential statistics? Do you actually, this is all the feasibility, right? The feasibility penalty. Did you run something at a level of fidelity that actually helps you to answer those questions? And so if you don't have that, inferential, particularly frequentist statistics, the p-value style you do, they're literally uninterpretable and they're actually dangerous. I mean, John Ioannidis has a very famous paper basically highlighting how most research is false. It is because of this exact problem. It's basically running stats that shouldn't be run on small sample sizes. That's basically it, right? And so it's a huge, huge problem. And it's just such a norm that, oh, I just run these quote limited efficacy trials, but not only are you not learning something, you're actually hurting the field. And here's how you're hurting the field, because what you're doing is you're running something that's not meaningful. And with this, add in the notion of a publication bias, basically only things that are positive are published, right? Things work the way you want them to work, right? So with this, if you get an effect size, particularly with a small sample, it is very high likelihood that that's not actually meaningful. What it is you probably just got lucky from a sampling perspective. It's basically, you just happen to get the 10 people who would respond well, right? You don't have the sample size to actually make anything meaningful from an inferential statistics perspective. And in so doing, you're going to be making claims on the effectiveness that are really, really dangerous and fraught. Now, technically, there are ways to actually handle this with Bayesians. You can actually use priors actually have papers articulating how to do this, but and I'd be happy to send that to you, but that's not, it's too complex. Don't do it. The recommendation is basically, so that's why it's bad. What you're told to do, that's why it's bad. It hurts science. And I think that's basically what you should say. And you can read the book for more concrete details. But what you do instead is something more like a proof of concept trial, where you basically say, here, I look at the evidence, I read the literature, I say, and I know my context, and you say, you know what, right now, our current best interventions for this thing I'm working on, they're going to get they're going to get this type of effect. Like imagine physical activity. I'll just pick that one for a moment, right? Imagine, our best case right now for physical activity interventions is that 50% of people meet national guidelines after 3 months. Great. So you're trying to get 55%, right? You got to do better than what's currently out there, right? And why is that more ethical? You're actually setting at a very basic foundational level. Am I building something that's better than what's currently out there? And if you're not, why are you doing it? Why would you waste millions of dollars running a trial that's just, even if it's effective, right? If you run a trial, you get to the end and you get something that's just as useful as everything else. great. You've just added more noise to the space. Now, of course, you might get into a question of like, well, maybe there's a matching algorithm, right? Maybe this one would work for a subsample or otherwise. That's great. That's fine. There's a great way to build evidence for that. That's called a sequential multiple assignment randomized trial. That is an optimization trial question. That is not, and that you can do it in phase 2 development, right? So you need to know clearly what your questions are to actually make that work. But sorry, I probably went into more than you needed, Donna, but did that give you enough?
Yeah, that's good. Yeah.
Educate the ethics.
Again, we're just having a problem, not only with the funding bodies, but with the ethics, not understanding things that are not actually have to be powered for a statistical result when it's just at that sort of feasibility stage of trying to see if something works. It's exactly what you were doing in number 1 with the armband, and they can't understand that. I think that to talk about the role of academia, Eric, another day, because we have another speaker, but we've got time for one last question. Does somebody know one more question? Yeah. Manos wants to have another go.
Stay, you're welcome. So you briefly touched, Eric, the diminishing positive effects, and I think that's another major issue when it comes to, I have wearables, always wearables in mind because physical activity is my field. That's another issue that sometimes I feel that published RCTs, they don't really address. And again, I'll go back to the structure of research funding and research that takes several years to acquire funding, and then typically RCTs are short term. The intervention is 6 months, then at best there will be a follow-up in a couple of years. I think everyone agrees that here that the goal with these trials and any intervention is automation and habit formation for long-standing behavior change. What is your take? How can research be more useful while operating in the current funding structures and short-term, relatively short trials? What is your take? What should we do so that we produce evidence that that gives us clues about the long-term effects of digital interventions, not the novelty, past the novelty the novelty period, let's say, past when the novelty wears off face.
Right. That's an awesome question. And maybe I will actually give you the take-home message to my role of academia, because you're kind of getting to it, alluding to it. Let me just show you the take-home slide. And I'm sorry, I actually fully unpack how I got here, but I'm not going to do that here, obviously. But it basically means, in my mind, we need to think very carefully on, is our goal to improve practice? Like, are we actually going to help real people in real world context? Or are we trying to get better at principles? Okay. And so I'm starting here to say, I think that we should be far more thoughtful about this. Like, we think that the short summary statement is the way that our current structure works. It actually is good if your primary goal is on building really innovative new tools and concepts. That's basically what our current toolkit is for. Okay. And so if you're making something that's just crazy out there, do efficacy trials, do the whole 4-phase element. That's great. That's fine. You're inventing a new concept. Okay. And why I'm starting here to answer your question is basically what you're doing there is you're trying to see if there's a there, right? You're trying to invent a new tool that can be brought out into the world. My sense is more often than not, that's not the only question that matters. Oftentimes, and this is now getting to the long-term work and sustainment, right? Those are questions of practice. You're trying to actually improve practice. And so on one hand, you can see this is why I'm really arguing for the idea that we should actually be embedded in companies doing real world work. Basically think about, I bring up the example of think about a health inspector, right? There's a federal health inspector, at least in the US, that goes to every meat packing group and food place and checks to make sure the food is safe and responsible. And it actually is good for everybody, right? Because the people get healthier food, but even the food industry said, we're glad you're here because you reduce our risk of getting into, problems and stuff like that, right? In my mind, that should probably be more of the way we work. We're not actually researchers paid by the DTX company. We're researchers paid by the government with the goal of basically advancing the public good. And in so doing, we now get access to working with those real world problems. And we actually have the pathway to actually meaningfully monitor and look at the sustained use of these technologies and notice. It's called voltage drop in the dynamic sustainability framework, which is the space. It's an implementation science framework from David Chambers, the diminishing positive effects idea. That's a way we could actually meaningfully do that. So in my mind, it actually shifts us to this idea of more of almost like food inspectors in digital therapeutics. That's one pathway. Another one, just to throw it out there, which is more of the pathway I'm going, is committing to communities and clinics and just focusing on improved knowledge. I think of this more as a system science, where the idea of system science is less about knowing if a thing works. I'm not trying to build a widget. I'm trying to get the flow between the widgets, between the systems to work better. And by flow, I mean flow of energy, resources, and information. Okay. And so when you understand the flow of energy, resources, and information in context, you're going to get better at predicting how to make things work in real world contexts. Okay. And so to me, and I frame it as tuning with my colleague MC Schrafel in particular. But to me, committing to the role of actually trying to tune the flow of energy, resources, and information with the different tools that actually exist in real world contexts is another way that also, again, invites you into time series to actually see how this would work, and it gets your success criteria on how do I make things better here and now. Predictive knowledge. The last one, just to flag, is system science, where you're actually studying the principles and frameworks of how resources, energy, and information flow between systems. I think there's a whole area for that, and there's some great books. These were ones I would suggest for you to engage with that line of working, but I don't have time to get into that. But so basically, know if you're studying principles or practice, be honest with yourself. Don't think that studying principles is actually going to help get into practice. And that's basically, I think, the trap that the funding sets us up. If the funding is telling us we can only study principles, when we realize at this point what we need to study is practice. And then own it, right? And so with that, I think you can actually then start in the current funding environment. I would invite us all to meaningfully challenge the assumptions that are being made on why we're doing what we're doing, basically. Because and oftentimes, at least here in the US, the hardest problem is not the funders, it's study section, right? So the problem very much is us. We are used to falling into group think when we fall into study sections and are expecting a certain type of checklist when we're looking at it. We need to turn our brains back on and actually ask the question, is this actually going to help anybody? Or is this somebody just like going through the checklist that we all think is appropriate? And in so doing, we keep reinforcing the same poor evidence production that we've been doing for far too long.
Fantastic, Eric. So I'm sure everyone will join in thanking you for a most thought-provoking presentation.
Thank you all for your time.
I do thank you for staying so late at work, and we will let you resume your evening with your family now. So thank you very much, Eric. I'll be in touch.
So much. Have a good night, everyone.
Thank
Or
you.
have a great day. Sorry, different time zone.
Bye. Bye. So I'm going to hand over to Stephanie Partridge. We're going to have 3 short presentations, and then I'll introduce Stephanie to you at the